I think we're live. Test. Okay, yeah, we're live. Okay, welcome back to the live stream, where today we're low-key just gonna be grinding. I have, let's see. I do want to review some of the leak code questions, like from Blind 75. Chat has arrived already. Is crazy. Already is crazy. That's so fast. Actually, wait, hold on. Let me turn this on. Hopefully this looks better. Some brightness. But yeah, I do just want to review some of the leak code questions. I think last time we were on. Yeah, I just finished binary search. So for today, I want to review binary search, and I want to start a linked list. I realized last time, whenever I was doing these leak code questions, I was just kind of moving on to the next one, but I never reviewed what I just learned. So it's gonna make it hard for me to keep up. So yeah, I'm gonna review binary search and then move on to linked list. That's the plan for today. Actually, I should also probably open up a Pomodoro clock. That focus timer, the aesthetic one. Focus, I think that's what it's called. Focus. Yeah. Actually, I should probably check if there's an actual Pomodoro like timer or like an app. Mic volume low? What do you mean? Is it actually low? Hold on, I can turn it up. It's like low-key max volume. Is it better now? Turn it even more up? Are you sure? Okay. Okay, how about that? Isn't this like high? No? Wait, Loki, let me check. Hold on, give me a second. Let me go to... Oh, shoot. More... Okay, hold on. More... Okay, hold on. Wait, this is good though. Wait, this is good though. If I do it anymore, it's gonna start bleeding. Like, it's gonna sound like really bad. If I do it anymore, bro, it's gonna start like spacing out in the high end. It's gonna like sound so bad. I don't know. I tested on my phone. It sounds pretty good. So, but yeah. Okay, I'm gonna let's see. Let's move this. Let's minimize that. Move this to a different tab. Take off that. Shoot. There you go. I wish there was a way to like minimize that. 45. Mumbling, that's crazy. I'm on a 1-day streak. I'm so proud of myself. So nice. Okay. How does that look? That looks not bad. There you go. That's not bad. The goal by the end of like next week is to fill. Oh, this is a big goal. I was gonna say it's to fill this up. It's gonna be kind of intense. By the end of this month for sure. But yeah. Okay, I think we should start grinding. What time is it right now? It's 1:07. So let's just try grinding out for like an hour. Oh my god. Are we on binary search? Yeah. Also, let me know if you guys want like an ASMR keyboard thing. I've seen some people use that in their streams, where they use a keyboard and they put their mic to it and just start typing. Pretty interesting. Okay, let's see what this does. forgot how rotations work. Not gonna lie. This is what I mean. This is the issue. Let's just start reading the code to see what it made. Initiate both. So 2 pointers. One at the start, one at the end. Result is the first value. While left is less than right, so we're moving these 2 pointers. If less is... Sorry, I think there's a reconnection issue. We're good now though. Okay, so I think I got. Yeah, I got these two done. I did these two also, bro. I don't want to do the hard question right now. At least I want to just do the other two. Okay, we can do reverse linked list. Come on, bro. Come on, bro. Actually, wait, this reminds me. I do need to share. Share that. Yeah, our Discord is now in the bio. Dude, I forgot everything about linked lists. Like, I genuinely forgot everything about linked lists. Okay, because it's gonna take longer. How long? 10 minutes? Okay, let's do it.
So today let's solve an easy question for reversal linked list. And this question is actually like a sub-problem that's needed in a lot of other questions, like linked list related questions, so it's definitely good to understand. So just like the problem says, we have a linked list, we've got some nodes, and we just want to take each of these links, reverse them, keep doing that with every link, and then this is going to be the new head, and then we're going to return that. And they tell us that this can be done two ways, iteratively, meaning with just pointers, and also recursively, and I'll show you how to do it both ways. So we can do this with two pointers because we want to reverse it. So like from the perspective of this node, instead of the next pointer pointing at 3, we want it to point at the previous node, 1. So if we want to do this iteratively, we can use two...
I forgot what the question's even asking. Okay, just reverse the list, okay.
Hey everyone, we can use 2 pointers like many problems. Now what are the 2 pointers going to be? We can have initially a current pointer, so we can initialize current to the first node, which is our head. And we can also maintain a previous pointer, which initially is going to be set to null. So for the first node 1, we're going to take the next point, 2 pointers like many problems. Now what are the 2 pointers going to be? We can have initially a current pointer, so we can initialize current to the first node, which is our head. And we can also maintain a previous pointer, which initially is going to be set to null. So for the first node 1, we're going to take the next pointer and reverse it. So now the next pointer is going to be pointing at null. So this is now going to be the last element in our new reversed linked list. So now we can shift our pointers. So we're going to take the previous pointer and then shift it to current, and we're going to take the current pointer and shift it to the next node. Now since we broke this link, we have to save this somewhere before we end up breaking this link, and I'm going to show you how to do that in save mode. Now since we broke this link, we have to save this somewhere before we end up breaking this link, and I'm going to show you how to do that in the code. So now our current is 2. We want to take the next pointer and reverse it, so the next is now going to be like this. So it's going to point at previous. So we can reverse the next pointer and set it to previous. And once again, we're going to shift our previous pointer to current, and our current pointer is going to be shifted to next. Now we're finally at the last node. We can once again update the next pointer of this current node. And so now when we update our pointers, previous will be here and current is going to be at null. This will be here, current node. And so now when we update our pointers, previous will be here and current is going to be at null. We've reached the end of our list. Now we want to return the head. How do we return the head? Lucky for us, the previous pointer is equal to the new head, right? So this is going to be our result. Just like in this is going to be our result. Just like in the drawing, we can initialize our pointers first. Previous will initially be null, current will start at the head. And we want to keep going until we reach the end of the list. So while current is not null, we're going to reverse the pointers. So we want current.next to be set to previous, and then we can shift our pointers, right? So we can update previous to previous. So we is not, and we want to keep going until we reach the end of the list. So while current
not null, we're going to reverse the pointers. So we want current.next to be set to previous, and then we can shift our pointers, right? So we to be set to previous, and then we can shift our pointers, right? So we can update previous, set it to cur, and cur is going to be equal to current current.next, but notice how we set current.next to previous before. So when we do this, we actually are going to have a temporary variable called next, which I will do at the first line when we start our loop. So we can save that in next. So then when we update current.next, we still have that next pointer. And lastly, we return the result, which we know is stored in previous when this loop stops executing. So it works, and this is next. We still have that next pointer. And lastly, we return the result, which we know is stored in previous when this loop stops executing. So it works, and this is actually the most optimal solution. The time complexity is big O of n, and the memory complexity is big O of 1 because we're just using pointers, right? No data structures or anything. But if we want to do the recursive solution, then the time complexity is also going to remain linear, but the memory complexity is going to be linear as well. So we're going to need extra memory. So it's not the best solution, but I'll still show you how to do it. So usually the best way to think about recursive problems is to break it down into a subproblem, right? So if our initial head is 1, we start at 1 and this is our linked list, right? But let's say I want to do a recursive call. Instead of reversing the entire linked list, I'm going to reverse the remainder of the linked list. So everything except this 1. So now I have a subproblem, right? Now I only have 2 nodes to deal with. But let's take it one step further. This is now my new head, right? And I'm going to break it down even more. I'm going to say reverse this portion.
I don't even know if I want to. I'm not going to watch the recursive part because I don't want to confuse myself. We can try though.
Show you how to do it. So usually the best way to think about recursive problems is to break it down into a subproblem, right? So if our initial head is 1, we start at 1 and this is our linked list, right? But let's say I want to do a recursive call. Instead of reversing the entire linked list, I'm going to reverse the remainder of the linked list. So everything except this one. So now I have a sub problem, right? Now I only have 2 nodes to deal with. But let's take it one step further. This is now my new head, right? And I'm going to break it down even more. I'm going to say reverse this portion. Reverse the subproblem, reverse only 1 node. So then, if we try to break it down even more, then we're going to get this is our sublist, right? But this is just null, so we can't really reverse that. That's the base case. So now we're at this, we only have 1 node and we want to reverse it. How do we do that? Well, the next pointer is pointing at null. Instead of that, we can take the next pointer and set it to previous. Not really, because this is recursive, and at least the way I'm going to do it, I'm going to keep the pointer pointing at null. So we technically reversed this portion, which is just this, right? It's just a linked list of 1. So now we're going to pop back up out of our recursive call, and now our job is to reverse these 2 nodes. So since we're at 2, we can access 3. So what I'm going to do is say, okay, the next pointer of this is actually going to be set to me, is going to be set to 2, where I'm at right now. But my next pointer, 2's next pointer, is going to be set to null. So notice that so far, we have done our job. We reversed a linked list of size 2, right? This is going to be the new head, and this is the tail. This is the end of the list. So we did our job of reversing it, reversing these 2 nodes, but we still have 1 more node, so we're going to pop back up out of our recursive call. Okay, so now we're finally at the last.
I'm not gonna lie, I'm not getting it, but it's okay. Let's see what else I've left. Okay, so we were doing binary binary search linked list. So we have we have a good ways to go. I think I'm gonna call it for today, but I'm gonna try to get through these on my own time. Finish linked list so I can start trees tomorrow. Trees, if I finish that tomorrow, I could, on Sunday, I could maybe try getting through these. Then with dynamic programming, but I'll low-key, if I get through trees tomorrow, Sunday, if I get finish backtracking and tries, trees, heap and graphs is what's important too. So if I get to tries on Sunday, and then I can try to get through these during the week, get through graphs on the weekday, and it'll set me up pretty well. Wow, there's so much. Okay, it's okay. We can do it. Because I'm not gonna do the hard questions, but okay. The goal is to finish linked list today, and then I'm also learning JavaScript. So I started this course, duplicate from the Odin project. I'm learning JavaScript, and I'm at projects, problem solving. So I can get through this in a week, I think. But yeah, I'm gonna call it. It was good. It was a pretty decent stream, pretty productive, and yeah. Okay, so I'll see you guys tomorrow then, or maybe later today. But yeah. Okay. Bye. Toodaloo. Have a great day. I see you tomorrow.